So this video we're talking about compound inequalities, and basically there's two types that we're going to deal with in Algebra 1. The type 1, it has an or in it. If you notice all these problems 1 through 5, it's like they have two inequality problems attached by the word or. So basically you're going to solve each one separately and then put the answers on the same graph. Okay, so X could be the answer to this inequality, or X could be the answers to this inequality and still be part of the solution set. Okay, now I want you, because this is going to help for when we talk about absolute value inequalities, I want you to think of the or as a great or statement. And so for now, just trust me, because that's going to connect nicely to our next lesson. And so basically, anytime there's an or, you're going to have basically two answers to two different inequalities. And X could be from either one of those and still be a correct solution. And of course, when it's an or statement, we want to take all of the answers together. Okay. So the second type that we're going to be talking about is, now there's an and. We don't really in Algebra 1 deal with the and. It's actually like a three-sided inequality where instead of just having a left and a right side like we're used to, you're going to have a left, a center, and a right side. The only difference is you're going to have the x in the middle, and you want to get all your x's in the middle. So I actually like to call it, which also will help with our absolute value inequalities, I want you to get used to this type as a less than sandwich, okay? Because if you think about it, like looking at this graph, none of the infinities, none of the arrows are shaded. So in fact, all the answers are sandwiched between two endpoints. Now it doesn't matter if the endpoints are open or closed or any combination. That part doesn't matter, but everything that's shaded in between those endpoints are going to be the solution, and they're sandwiched between the two endpoints. And I use a less than sandwich because, well, actually, let me get into that in a second, okay? I want to talk about these ones first. So, and I'm not going to worry about a definition at this point, but we can take a graph and read that graph to the written inequality solution. So basically, if we look, we have a solid point on -2. So that's our first boundary point, is -2. And we know that the arrow is going to the left. I could fit a less than sign around that shaded arrow. We know that we need the variable on the left side so that the inequality matches the arrow that's being shaded. So if we put the less than sign, x is less than, and then we put the boundary, which is -2. Oh, and don't forget, because this -2 has a solid point, we need the or equal to. And this gap basically represents the or, because this side is not connected to this side. So it could, x could be either on the left-hand side of the graph, or x could be on the right-hand side of the graph and still be a solution. So that's what the or means. The next number or boundary is 2. And we can fit a greater than sign around the shaded arrow, which basically means that we can use the greater than sign as long as we keep the variable on the left. Because as long as the variable is on the left, we can use the inequality as pointing in the same direction as the arrow that's being shaded for the solutions of x. Now, we're going to keep it strictly greater than because it's an open point on the boundary, and we know x has to be greater than or equal to 2 since 2 is the boundary. Okay. So this will be your first solution where you're solving these problems algebraically by working backwards. Now, they gave you the graph right here so that we could discuss what the written statement looks like. But once you get your final answer that looks similar to this for each of these problems, you're going to graph on the number line your solution using the proper solid or open points and shading. but we're also going to do the interval notation that was discussed in the last lesson on multi-step inequalities. So for this, again, interval notation, we always read from left to right on the graph. So if you look at the graph, because we have, let me put my or equal to, because we have hit the arrow on the left first, we know to the left the numbers keep going down to negative infinity forever and ever. So we're going to write negative infinity, and then we keep going and it stops at negative 2. Now from the interval notation, we know we use the parentheses on the negative infinity because the parentheses allow it to keep going forever. The negative 2, because there's a solid point, we're going to use the square brackets. Okay. The only thing that's new is with interval notation, we don't use the word or, we use a U. Basically the U stands, it doesn't have the little tail. It's a U, which is union. And basically this means or for interval notation. Okay. So then, so we had our negative infinity to negative 2 with the solid or the square bracket on negative 2 because of the solid point. We have the U, which represents the or for the gap. Then the next thing we hit is the positive 2, but because it's an open circle, we're going to use the parentheses because the parentheses mean we can get infinitely close to 2, but x can never actually be 2. And then the last thing we hit is the arrow, which shows that it's going to the right infinitely to positive infinity. So we're going to write positive infinity with the parentheses. So this is your interval notation. Okay. So the first thing, let's actually, there's one other rule I want to remind it. For number 2, it just reminded me. And this is the rule that should pop in your head anytime there's inequality symbols, okay? No matter if there's absolute value, compound, multi-step, any inequality, you have to remember if you divide or multiply both sides by a negative number, then you must flip the inequality. Okay. Now I gave you the tip last time that if all your variables are on the left side and it has a negative coefficient, you know you're going to end up flipping it because you'll have to divide both sides by a negative, like number 2. So don't forget to do that, and you're going to actually do that on your own. But let's do number 1 together. So basically, I'm going to treat this like 2 separate problems. That's where my line is drawn. I'm going to show my work on the first inequality over here, and then my work on the second one over here. So just like there's a left side and a right side, I want to solve for x on the left side, so let's add 4 to both sides. You get x is less than negative 3. There's nothing more to solve, so that's our first part of our answer. The second one, we only have to divide by 2 on both sides, and since there was a positive coefficient and we're dividing by a positive number, we do not need to flip. So it's just x greater than or equal to 6. So basically, this is our final answer. Actually, now I can erase my work line. I'm not going to write that on the other problems. I just wanted to emphasize that these are 2 separate problems you solve, but both together create the full solution. Now, so this is the first answer I'm looking for. The second is to graph both of these. So let's graph the first one. So let's find negative 3. And because it's strictly less than, we need an open point on negative 3. And since the variable's on the left side, we can treat the inequality like an arrow, and we shade everything to the left. Then we have a gap, and we go to positive 6. And because of the or equal to, we're going to do a solid point. And again, because the variable is on the left side, we can treat the inequality like an arrow, so it's pointing to the right. So there's our graph that matches our written inequality answer. Now our interval notation, so we just read from left to right. Well, on the left, we know the arrow pointing to the left is negative infinity, and it ends at negative 3. That's our boundary point. but since it's an open point, we put parentheses on the negative 3, and we're going to keep parentheses on all of the infinities, whether it's positive or negative, okay? And then we use the U because that means or, that's in place of the word or. The next thing we hit is that 6, so we use, and it's a solid point, so we use a square bracket, and then it keeps going to positive infinity, and that's at the end of the right-hand side. And we close that with a parentheses, okay? So let's look at number 3. So again, we're going to solve each one of these separately. So the first one, since it's 2x plus 9 is greater than 17, let's subtract 9 on both sides. So we get 2x is greater than, and this is going to be 12, and divided by 2, so x is greater than 6. And I'll just put my or because I know I have a second part. Then the other part, so 5x plus 10 is less than 10, so we have to subtract 10. And I'm actually really happy about this example to emphasize something we've already talked about. It's okay to get 0 on one side of the equation. So if I have 5x and the 10 minus 10 eliminates, I only want the variables on the left side, but then 10 minus 10 eliminates, and we need a constant. Anything that eliminates is going to be 0, okay? It's okay to get 0. Because the variables didn't eliminate though, we know it's not a case of infinite or no solution like we talked about in a previous lesson for equations, okay? So we divide by 5 on both sides, and we get x is less than 0, since 0 divided by 5 is 0. So this is the first written answer. Now let's graph it. So we start with x is greater than 6, so we go to 6. Since it's strictly greater than, there's no or equal to, we put an open point, and with the variable on the left side, the arrow points to the right, or the inequality acts like an arrow pointing to the right, so we shade to the right. Then we go to 0, that's also an open point, because there's no or equal to, and this time the inequality with the variable on the left is pointing to the left, so it acts like an arrow. So that's our graphical solution. Now, we write our interval notation, and we always do it from left to right. So since we hit the arrow on the left, it's negative infinity going to the left, then it ends at 0, and since the infinity always has a parentheses and the 0 is an open point, we put parentheses. The union represents the or, which is the gap. Then we hit 6 as the boundary point, and it's an open, so we put a parentheses. And the arrow keeps going to the right, which is positive infinity, and we always put parentheses on the infinities. Okay. So look at number 5. Again, we're going to basically solve each one separately, but I can kind of, my little tip, I can tell since there's no other variables on this inequality, I know I'm, for the last step, going to be dividing by -6, which means in the last step, I'm going to be switching the inequality. And frankly, I look at this one and I can tell I'm also going to be flipping the inequality since all the variables are on the left on the second one, and there's a -1 coefficient. So, but first we have to undo all the adding and subtracting, but I just wanted to emphasize that tip that I've talked about in the previous lessons. So first thing we do is subtract the 3 on both sides. So we get -6x is less than, and both are negative, so we combine them to -18. Divide by -6, and then all the signs change. The inequality is no longer true, so we get x is greater than +3. We have to flip the inequality, and now it's true. Okay, then or, over here, you gotta remember, okay, the negative is on the x, not the 1. 1 is positive. The only way we can eliminate +1 is with -1. So we add -1 to both sides. We still have the -1x, and I'm just gonna write the 1 to emphasize that there's a 1 as a coefficient, greater than or equal to 4. So we go ahead and divide by -1. It flips the inequality since we're dividing by negative on both sides, and x is gonna be less than or equal to -4. So this is our first answer. So here's +3. We have an open point on +3, and we shade everything to the right. Now on -4, you do a solid point on -4, and you shade everything to the left. And then to write our interval notation from left to right, so it goes from -infinity to -4, we use a square bracket for the solid point. The union is the or the gap. Then we have +3 with an open point, so it's a parentheses, all the way to +infinity, which is the arrow on the right. So go ahead and do 2 and 4 on your own. Okay, I gave you the answer for 2 and 4 for the written inequality. I did not show the graph or the interval notation because I want you to come ask if it doesn't make sense. Okay, so for the type 2, my less than sandwich. Now, I want to finish the explanation of the less than sandwich. So you notice all the 2 boundary points. So we have -2 is the lower boundary, and we have the 1 is the upper boundary. And all this shaded in between represents what x can be. So x is sandwiched in the middle. And the reason why I say less than sandwich is because you use only less than signs, and because we keep it strictly less than for the -2 because it's an open point. But on the 1, it's a solid point, so we put the or equal to on the inequality by the upper boundary, which is 1. Okay? And the interval notation is actually really simple because we have no infinities and it's all together. So we just go from -2 to +1, and since the -2 is open circle, we put a parentheses, and because 1 is a solid point, we put the square brackets. So the interval notation for these less than sandwiches are really easy. And I kind of talked about in the overview that we want to get x all by itself, and we no longer have just a left and a right side. We have a left, a center, and a right side, and we always want the x in the center. Okay. So in this case, if I look in the center, I have x plus 4. This plus 4 is what I need to undo or get rid of to get x all by itself in the center. So I subtract 4, but I have to subtract 4 not just from the center, I have to do it from the left and the right side. So that we know the plus 4 and the -4 eliminate. And then we just simplify 2 and -4 is -2 less than or equal to x less than 5. And we're done, and we know we're done because the x is all by itself in the center. Okay, so that's our first answer. So then on our graph, we go to -2 is a solid point, and then +5 is an open point, and then you shade everything in the middle. Okay, so our interval notation is from -2 to +5, but we have a solid point on -2, so we put the square bracket in front of the -2, and the +5 is an open point, so we put parentheses around the 5, and we're done. So let's look at number 8. Actually, I'd like to do number 8 is really close to number 6. Let's do number 7. So for number 7, notice we have 7x in the middle. So there's only going to be one step, and since 7x means 7 times x, all we have to do is divide by 7 on all 3 sides, and then simplify. So we get x, or -2 is less than x is less than 3. That's our final solution since the center is x all by itself. Then over here, we just put our open point on -2 and an open point on 3 since there's no or equal to's in the problem, and we shade in the middle. Okay, and then our interval notation is from -2 to 3, and that's our final answer. So let's look at number 9, and then I'm going to have you do 8 and 10 on your own. This we have 2 steps. Basically, we always undo the adding and subtracting before we undo any of the multiplying and dividing because we're working backwards on the order of operations. So we add 4 to all 3 sides, and you get -12 is less than or equal to 3x is less than or equal to 6. Now we do the division to all 3 sides, and you get, I'm just going to write it over here, so -4 is less than or equal to x is less than or equal to 2. So that's your written inequality answer. So we graph it, we go to -4, it has an or equal to, so we put a solid point on that boundary. And then number 2, we also put a solid point. And since X is sandwiched in the middle, we shade it in the middle. So go ahead and, like I said, do 8 and 10 on your own. Pause the video and check the answer key at the end, and bring any questions that you have in class. Okay, so I'm giving you the answer for 8 and 10, but I'm not giving you the graph and the interval notation, so that if you're not sure how to do that, you need to come ask me